Greenland and Antarctica are home to most of the world's glacial ice that accumulates on land, including its only two ice sheets. That's why scientists focus their energy here first when looking for answers about sea level rise. Here's a concerning reality. Combined, the two regions contain enough ice that if it were to melt all at once, sea levels would increase by nearly 215 feet. Now, that isn't going to happen anytime soon, but even a few feet of sea level rise, much less 215, would be disastrous for the planet's coastal communities. For most people, these processes are happening so far away that it's hard to imagine how melting at the poles even occurs. Let's lay some groundwork. A healthy glacier is one that accumulates the same amount of snowfall as it loses. It's a system in balance. Unfortunately, today's glaciers and ice sheets are not in balance. Here's what that actually looks like. In Greenland, when warm summer air melts the surface of a glacier, the meltwater drills holes down through the ice. It makes its way down to the bottom of the glacier where it runs between the ice and the bedrock, and eventually shoots out in a plume at the base of the glacier. The meltwater plume is lighter because it doesn't contain salt. It's fresh water. It rises toward the surface, mixing warm, salty ocean water upward in the process. The warm water then rubs up against the bottom of the glacier, causing even more of the glacier to melt. This often leads to calving, where ice cracks and breaks off into large icebergs. In addition to melting caused by warm air and a warm ocean, Antarctica faces another challenge: the bedrock itself. Researchers often split Antarctica into two regions, East and West. Unlike East Antarctica, the bedrock that makes up West Antarctica is below sea level, which means it's actually underwater. Warmer water has an easier time seeping in between the continental shelf and the ice sheet, melting the ice from below. This causes the ice shelves to thin and break off into the ocean. Melting and ice loss have accelerated at both poles in recent years. The more we learn about this complicated process, the more accurately we'll be able to predict sea level rise far into the future.